All right, so here we are at section 4 of chapter 11, which is the area of a kite or any related figure to a kite. So what do you think would be a figure that's related to a kite? So if you think about like a rhombus or a square, those two shapes are special kites. So the formula that we have for a kite will also work for the formula to figure out the area of a rhombus or even a square if we so choose. So here's the formula for the area of a kite, which is 1/2 the product of the diagonals. So if you take diagonal 1 and multiply it by diagonal 2 and then take half of it, that will get you the area of your kite. So why do you think that is? Why would we ever want to take both diagonals, multiply them together, and then half of it? Well, let's take a look at this. A kite could be considered two triangles kind of attached together, either at AB, or I could have cut it down the line here and had triangle on left and right. What we're going to do is we're going to do the top and the bottom. Okay, so the area of our kite is going to be the area of the top triangle added to the area of the bottom triangle. And we have a formula for the area of a triangle, right? 1/2 base times height. So let's start this off. The area of the top triangle is 1/2 your base, which is AB, times your height, which is DC. And then the bottom triangle is 1/2 your base, which is also AB. And then this time your height is CE. So using this formula, we would add those together to get the area of the kite. And if you notice, there's 1/2 AB here, there's a 1/2 AB there. Those are common factors that we can pull out. So we can factor those out, use some algebra. Okay, so we have 1/2 AB. And what is left over was the DC added to the CE. So if you think about it, if you distributed this through, you should get what you have up there. Now, if we go back to our diagram and we look at what DC plus CE is, over here, DC plus CE, well, that's the entire diagonal DE. So we can replace that. So now it's 1/2 AB times DE. And look at that. That's diagonal times a half. You got it. Okay, so now let's actually do a problem. Oh, we already talked about this. Okay, so let's take a look at a rhombus. So a rhombus, we're supposed to find the area of whose perimeter is 20 inches and whose longer diagonal is 8 inches. So that's all the information they give us. We need to figure out the area. So if the perimeter is 20, we should know that each side of that rhombus is going to be 5. And then the longer diagonal is 8. Something that you have to remember about rhombuses is that the diagonals are perpendicular bisectors of each other. So not only are these right angles, but this diagonal has been split in half. So I know that both of those are 4. Now, because this is a right angle and we have 4 and 5, I bet you're guessing, hey, this is 3. Okay, and you'd be right. So if that's 3, then this is 3. So the short diagonal is 6. So if we go to use our formula, 1/2 diagonal times diagonal, we end up getting an area of 24. Okay, so that's not too bad. But what if they ask you to now find the height? So they want the height of the rhombus. Okay, so think about how you might do that. So they're asking like, what is this height right here? Okay, well, remember in a rhombus could be considered a parallelogram as well as a kite. So the formula for the area of a parallelogram is just base times height. And we have the base right here, and we have the area. So if we just plug that in, oh, there's our height. Okay, so the base times height, our area is 24, base is 5, we're looking for the height. Now we just solve for h, and we get 24 over 5. Pretty simple. Okay, but you just have to remember that now you have to think of this as a parallelogram as opposed to thinking of it as a kite. All right, excellent question. Good. I think we're done.